continue our discussion. So today we are going to discuss few questions from your previous year NEET exam. So this is, I guess, from 2024. Okay. So what is happening here? The radius of gyration of solid sphere of mass 5 kg about xy axis. This is xy axis is 5 meter as shown in figure. Okay. So here we have a sphere and this is axis given here, and radius of gyration for this axis is given, mass is given here 5 kg, and radius of gyration is also given here 5 meter. So with these two things we can obtain what is the moment of inertia about this xy axis, and this is total mass times a square of this thing. So we can do it easily. This will be 5 and this will be 5 square, that will be 25. 25 into 5 will be 125 units, which is kg meter square. Now the radius of the sphere, so let's say this is center and then this will be radius. Let's say radius of this sphere is capital R, which is given here. So we can write using a concept which we call parallel axis theorem. We can obtain what is the moment of inertia this ixy, means about this xy. As we have obtained this thing here, numerically we have this value here. Now we can obtain this using parallel axis theorem, and then we will equate those two things to get the value of x, which is given in its radius. So we can write ixy will be moment of inertia of this solid sphere about the axis passing through its center of mass. So its center of mass is its geometrical center. So we can say that about this axis, which is passing through its center of mass, the moment of inertia is I cm. And if we want to know about this, so how it happens? Ixy can be given as the sum of moment of inertia about an axis which is passing through its center of mass and plus mass of this sphere times this distance, this perpendicular distance squared. So m r square. This is how we have already discussed this thing. So we know that moment of inertia about center of mass in case of solid sphere is 2 by 5 mass times r square, and then we will have to add here m r square, and it will be, I guess, 7 by 5 m r square. Now we have obtained ixy here in terms of r. Now we can equate these two things here and one is here. So we can equate these two things. So we will have 7 by 5 m r square equals to 125, and this will be 7 by 5. M is also 5 kg and r square will be, here we have r. So this will be 5x by under root 7 and a square of this thing. And this should be equal to 125. In the next step, we can look, we can just do here. So 7 into 25 x square divided by 7 equals to 125, and from here we will get 25 x square equals to 125, or we can get x square equals to 5, or we can get x equals to under root 5. Okay, so we are not going to use negative thing here because it is here in radius. So radius is a kind of length in this case, so we are using only positive of this square root. Otherwise, x square equals to 5 will give us x equals to plus root 5 and minus root 5. But we are using only positive thing here so that the length will remain intact here. Now, let's move to the second question here. So, what is happening? Here we have given omega 1, omega 2 and omega 3 be the angular speed of the second hand, minute hand and hour hand of a smoothly running analog clock. So, you know analog clock, which is a kind of clock having second arm, minute and hour arm. So this kind of clock. So if x1, x2 and x3 are their respective angular distances in 1 minute, then the factor which remains constant is. So we have to obtain which one is correct relation here. So let's continue our discussion. So we will start with this second hand. So in 1 minute, okay, in 1 minute, this second hand completes 2 pi radian, means it completes one complete revolution, or more precisely rotation. So in 1 minute, second hand covers an angular distance of 2 pi radian. Okay, so we can say that x1 is 2 pi radian, and omega 1, let me write it in radian per minute. This will make it easy. So 2 pi radian per minute. Now coming to the minute hand. So minute hand, in case of minute hand, this covers one complete rotation in 60 minutes. So in 60 minutes, it covers an angular distance of 2 pi radian. So in 1 minute, it will cover 2 pi by 60 radian. So we can write x2, that is angular distance covered in 1 minute will be 2 pi by 60 radian, and omega 2 will be 2 pi by 60 radian per minute. Now the third one, in case of our hand. So in case of our hand, in 12 hours, this hour hand completes one revolution or one rotation. So in 12 hours, that is 12 into 60 minute, it completes 2 pi radian of angular distance. So in 1 minute, it will complete 2 pi by 720 radian. And if it is completing this much angular distance in 1 minute, we can write x3 equals to 2 pi by 720 radian, and omega 3 will be 2 pi by 720 radian per minute. Or now you can easily recognize which one is going to be correct here. So you can see it. Omega 1 divided by x1 is 1. Omega 2 divided by x2 is also 1. From here, you can see these are the two numbers. So omega 3, x3 also 1. So we have the correct thing here. Okay, you can change it in second to get angular velocity, but that will be actually increasing the length of your calculation. So it will be better to keep it in radian per minute so that we can obtain the things easily.